Okay, right. I'm so. So I have your shot.
Doing. Okay. Okay, so we're starting unit 3 today. So today we're going to go over 3.01. Talk about law of sines. We're going to just really practice with that worksheet. First few pages. Tomorrow there's a check-in quiz, but I promise you won't have to study for it. It'll just be one problem. We'll do a practice problem before you take that check-in quiz, so it'll be easy. Okay, just one problem. We're going to do a lot of practice today, but we'll still do a practice before you take that quiz. It'll take like 5 minutes. Okay. Okay, right triangle trig. So trig is the study of triangles. Can be used to solve problems involving right triangles. However, many interesting problems involve non-right triangles. Okay, so in this lesson, we'll be using right triangle trigonometry to develop the law of sines. Law of sines is important because it can be used to solve problems involving non-right triangles as well as right triangles. Okay, so it says consider the oblique triangle here. Oblique just means a non-right triangle. Okay, sketch an altitude from vertex B. So from B, you're going to draw a line down so that it will intersect at a 90-degree angle with AC. Call this K. Okay, just some review here. Uppercase letters are talking about angle measures of a triangle, and then the lowercase A, B, and C are talking about the side lengths. Okay, and then your lowercase side length is always across from the uppercase angle, right? So angle A is here. Across from angle A will be side A. Angle B is here. If this is angle B, then across from it will be side B. If this is angle C, then across from it will be side C. Everybody okay with that? All right, the altitude creates two right triangles inside the triangle ABC. Notice that triangle or angle A is contained in one of the right triangles and angle C is contained in the other. Using right triangle trig, write two equations involving sine A and involving sine C. So we know sine is opposite over hypotenuse. So sine A, what's sine A going to be? A over C, yeah. Sine C will be what? A over A. Okay, notice that each equation in question 3 involves K. And let's go ahead and solve for equation K. So I'm going to solve for K for each of these equations here, cross multiply. Now, since both equations in question 4 are equal to K, they can be set equal to each other. So we can say C sine of A, sine C sine. So it says, notice in equation in question 5 no longer involves K. Rewrite the equation in question 5. Regrouping A with sine A and C with sine C. So divide both sides by A and C. I'm doing a double division here. I'll move the A to the denominator on this side, and I'll move the C in the denominator of the other side. Okay, so this is going to be really helpful in helping us find missing sides or missing angles whenever we're given parts of the sides or angles of a triangle, but not the whole thing. But you're more than welcome to flip this around if you like. You can say sine A over sine uppercase A is equal to C over sine uppercase C. Okay. You mean from here to here? Or from 5 to 6? 5 to 6. So what I did was I divided lowercase a to the left side. So when I divide it over, it's going to end up in the denominator of the left side. And when I move that C over to the right side, if I divide by C, C is going to end up in the denominator of the right side. Yeah, question.
How do we get from 3 to 4? Oh, never.
We just cross multiply, right? Yes, question.
So why do you divide KC and like the lowercase a into the other?
Because it's just it's easier to see that relationship, easier to memorize this than it is this, knowing that your sine A and lowercase a, side length and angle are going to be grouped together. Angle C, side C is grouped together. So this is what we call law of sines, and we're going to have to memorize it, but it's easier to have the angles and sides together. Because they're the same thing. You can either do this way or this way, as long as you're consistent. If you want your angle A up top, then your side length is below. Yeah.
Are you to the point where like when you do actual like numbers, it'll like just gets like
Yeah, this is basically just a formula, and we're going to be able to use this formula to help us find missing sides of a triangle.
So you want to do the other part beforehand, but just go right to that.
That's right. That's right. Yeah. From now on, you're just going to go directly to here. All right, let's go to the second page, page 4. Okay, so now we're going to sketch an altitude from vertex C to the opposite side. So I'm going to try to create a right perpendicular. Okay, same idea here. Sine of A is equal to K over V. Sine of B is equal to K over A, right? Opposite of our hypotenuse. Cross multiply again. I'll divide the A and B over to the other side. It'll be easier to group them and memorize them. So if sine A over A equals sine B over B, and sine A over A equals sine C over C, then we can just set them all equal to each other. So this is what we call law of sines. Very useful in helping us find missing sides, missing angles of a triangle. Or you can write it this way. Up to you. Yes. I'm sorry? Because if sine A over A equals sine B over B, then if I flip everything, then my relationship is still the same. If I flip one side of the equation, I can flip the other side of the equation, as long as I maintain balance. Okay, so law of sines is important because it can be used to solve problems involving both right and non-right triangles, because it involves only the sides and angles of a triangle. Okay, so let's put this into practice. Page 5. Okay, so for number 1, we'll draw and label each triangle. Again, your triangle does not have to be accurate. As long as you have something to work off of, that's good enough. Okay, so I'll call angle A 40. Angle C is 70. And A is 20. So A is the side length that's across from the angle A. Let's see what we can do before we jump into law of sines. Can I find missing angle B? What do you know about angles inside a triangle? Totals to be what? 180, yep. So if I subtract those numbers from 180, I can get angle C, angle B. Okay, now do you know what type of triangle this is? Isosceles. What's special about isosceles triangle?
3 seconds.
So these are the same. So if I can find one side, I can find the other side just by filling that in. So when we do law of sines, we only do 2 at a time. Okay, we either pair up A with sine A, B with sine B, or you can do A with sine A, C with sine C, or you can do B of sine B over C of sine C. Okay, so this is side B. This is side C. So how would you what would you definitely want to use if you want to go through this process? Involve what, for sure? Definitely involve A, because A, you have full information, right? You have angle A and side A. We don't want to be doing B and C because then we're left with too many variables, right? We want to solve one variable at a time. So why don't we do A and B? So we'll follow this form here. 20 over sine of 40. That's right, good. Yeah, bring your calculator back into degrees. Okay, B over sine of angle B, which is B over sine of 70. Cross multiply. Let's round to three decimal places. So if I know side B is 29.238, what do I know about C? Same. Yeah. Okay, so we're just practicing with this concept today. We'll do 2 through 5. And I'll show each step of the way as you guys have a chance to try it, okay? Now, number one was a little bit easier because after you solve for one variable, you can just fill in with the same value. But if we're dealing with a triangle that's not isosceles, we got to go through the process twice. All right, once to solve for A and once to solve for C. have to. I just find it helpful to see what I'm dealing with. Yeah, you don't have to though. Marking helps.
You already scratched paper.
Sure. Anyone else want scratch paper? Feel free to grab one at any time if you need it. Okay, hope you guys find this easy. I'll come around and just see how you guys do. I'll put up the answers after a few minutes, but I'll walk around as well to see if you have any questions. After about 10, 15 minutes, we're good with 1 through 5. We'll tackle some more problems.
This is all. This is one of these.
Yeah, it's just like, it'll look like 1 through 5, one of those problems.
Question, so like, when you're drawing a triangle, how do you know what to associate which angle which for the plane change?
Good, okay, so the way that we know is, now you may not have your angles the same orientation as me, but what you need to make sure is that your angle C and your side C are always across from each other. Angle A and side A always across from each other. Angle B and side B always across from each other.
So it doesn't matter how you draw, like, what,
No, it doesn't matter. But I can't have angle C here and call this B.
right?
And the uppercase is angles, lowercase is sides. Okay.
It's pretty easy though.
I know.
Any questions, 1, 2, or 3? Okay, your quiz will just be one problem. It'll look like 1 through 5. We'll do a practice one before we take the quiz. But I want us to move on to the word problems. I want to introduce the 2 word problems to you, and then we'll be done, okay? Is anybody still working on 4 or 5? Okay, let's look at number 6. Hey, a landscaper wants to plant begonias along the edges of a triangular plot of land. Do the angles measure 95 degrees and 40. Size between these two angles is 80 feet long. You can name your angles any way you want, but just for frame of reference, I'm naming it this way, but you don't have to do it this way. Find the third angle, subtract from 180. I have angle C and side C, so I'm going to take advantage of that to help me solve for A and this solve for B. Let's multiply. Okay, do the same process, find side B. Now that you have everything, you either pair B with A or pair B with C. Finally, what does perimeter mean? Out of all three sides. Yeah.
So I'm doing 45 sine 95 over sine 80, but I'm getting a different answer though. What am I doing?
Are you in, you did 45 sine 95 over sine 80?
I did,
Are you in the degree mode?
I think so.
Okay, let me see. That's fine.
So you got.
Yeah. Oh, are you guys getting 25?
6.569 and 79. The last is 40. No, 45 is the.
Oh, my bad, my bad. I got my angles mixed up. Sorry, I mixed this up. That makes sense. Sorry, I got the angles and size mixed up. Sorry, I got the Yeah.
A different.
This one.
What is A?
A is supposed to be 112, which is right. This is right.
Uh,
But my work was wrong, but now it's right.
Okay, I'm gonna read those. I did it.
Yeah. Yeah, future, it helps, but right now, you really don't need it that much. All right, guys, one last problem.
It doesn't really matter how the triangle is up, right? As long as the triangle level, they're level. I know, I can't see it. I just, yeah. And, it's not, it's a budget. A still equals 40. Really, so now when I thought, oh my God, what did I say? I said, oh, no. There's nothing what it was to say came out of the. See, I was right. Okay, so I just don't know what it's. The first time they ever did Russell was without. It was also my. I didn't know. Why just had it was fine, but it's fine because they're even like.
Hey, guys, I didn't leave enough room for number 7. Let's spend time going over this tomorrow after our check-in quiz. So tomorrow, we'll do practice problem, do the check-in quiz, finish up 3.1 and do 3.2. All right, come get your phones.